Good morning, good afternoon, everybody. This is Nick Chalon. Thanks so much for joining this next episode of In the Nick of Time. We're going to get started in about 12 minutes now. It's going to be a very interesting episode today. We're going to be talking about a lot of great topics around software, bill of materials, and supply chain with our great, amazing guest joining us today, Kate Stewart from the Linux Foundation. So stay tuned. In about, what is it now, 10, 12 minutes, we're going to get started. In the meantime, if you want to share you're here with us, please put your name and maybe your company in the comment section below. Also, if you want to subscribe to the Nick of Time, go to inthenickofTime.tv to subscribe to get an email every time we launch a next episode. Also, if you want to become finally a member of Learn with Nick, go check it out. It's finally up and running, and we have two coupons code, 50% off for military and civilians with the code military, and then 20% off for early adopters that use the code Let's Beat China. So stay tuned. We get started in about 10 minutes. Good morning, good afternoon, everybody. Thanks so much for joining this next episode of In the Nick of Time. We're going to get started in about 5 minutes now with Kate Stewart joining us from the Linux Foundation. It's going to be a great episode, so make sure you start asking your question in the comment section below. Start with a Q. Also, if you want to share you here, just with your name and maybe the company you're with so we can highlight you on the screen. And like I said, we just launched Learn with Nick. This week is pretty exciting. We have already quite a lot of people subscribing. So if you want to do that, go to the website and you can use 2 different coupon codes, military for military and civilians, 50% off. And then, of course, Let's Beat China for everybody else with 20% off. Stay tuned. 5 minutes. Good morning, good afternoon, everybody. Thanks so much for joining this next episode of In Nick of Time. This is going to be a pretty exciting one. We have an amazing guest today. Kate Stewart is with us from the Linux Foundation. We're going to cover so many topics, and she has such a huge breadth of expertise, both in software, supply chain, and bit of material, but also in real-time operating systems and how to bring safety and security together in a world of embedded systems. So it's going to be a lot of fun today. Before we get started, I wanted to remind everybody, of course, to subscribe to the show if you have not done so yet. Go to inthenicoftime.tv and make sure you subscribe so you can get one email every week to tell you about the next episode coming with the next guest. Also, if you missed it, we have launched finally the Learn with Nick platform just last Monday, yesterday. So if you want to finally check it out and maybe try it out, let us know also your feedback and what's missing, what we could improve. We got such an amazing success in one day. So many companies, Fortune 500, but also individuals subscribing to the platform yesterday. If you want to try it out, go on the website learnwithnick.com, and you have two different coupon codes if you're military or civilian in the U.S. government. Make sure you use the coupon code military. That gives you a 50% off discount. And then if you're just an early adopter, so pretty much everybody else would use the coupon code Let's Beat China. And that's limited to 1,000 people. And we're getting close to that. So you probably want to do that now, and you get 20% off there. Just so you know, the model is really a community. It's not just a learning platform. We're going to have new content every week, both videos and also every other week. We're going to do a live Q&A session with the members for 2 hours with me live, so you can ask questions. We have so many telcos, healthcare companies, financial institutions, but also different NATO nations, and of course the US government agencies coming and asking questions on how to bring DevSecOps, digital transformation, zero trust to the largest organizations on the planet. So we see people, bringing Kubernetes on 5G systems at the edge when it comes to telcos, all the way to what we've done in DoD on jets and bombers and space systems. So it's a lot of fun. It's going to be continuously updated, and more importantly, we're going to have amazing guests. Kind of think of a kind of the masterclass for software. We're going to have a dear friend of mine join and do their masterclass concept on Learn with Nick with different topics like architecture and cyber and digital engineering and modeling and simulation. So it's going to be a lot of fun. So check it out. Let us know what you think. If your company you think would be interested in joining, we have bulk discounts for volumes. Several banks and telcos are buying 200-300 seats at a time. And so make sure you let them know, or you let me know to reach out to them to get you access. If you think that's easier for you to go through your company, that's definitely an option as well. All right, enough with that. Wanted to start bringing, and just so you can see maybe some of the content quickly, we have obviously everything from a deep dive on the technical side on GitOps and Service Mesh and Kubernetes and containers and so on, all the way to culture and acquisition. And we're going to do a deep dive also on acquisition, agile acquisition, obviously. But you see also, how to make sure you're not building software in a vacuum, fail fast, learn fast, don't fail twice for the same reason, how to enable teams to focus on their mission software, how to properly measure their DevSecOps maturity, and how to prevent change management from becoming your largest bottleneck. So all these are very short and sweet videos to the point. To get to understand all these challenges with, of course, tangible solutions that we leveraged in the Department of Defense with a lot of large teams. So hopefully that helps you get it done in your team and organization. So, all right. So Kate, before I bring her on the screen, you're going to see she has just such an amazing breadth of experience. We're very lucky to have her today. Obviously, she works with the safety and security and license compliance community. So it's a pretty interesting take on the balance between, of course, the compliance, safety, and security, while of course, trying to innovate. And so she has brought all these concepts with the adoption of Linux into the embedded open source projects. She's one of the founders of something we talked about already, which is the SPDX format for software bill of material, pushed now by the Linux Foundation. And she's also the co-lead of the NTIA SBOM formats and tooling working group that's been leveraged by the White House to write the executive order on zero trust and SBOM. Since she joined the Linux Foundation, she launched ELISA and Zephyr, two projects we'll talk about today. So if you don't know about them, you're going to learn a lot today. And it's pretty amazing when she started describing it, both of those projects to me. I started to realize kind of the amazing value this brings to the table for organizations dealing with embedded systems and safety concerns. She has 30 years of experience in software industry, held many different roles, both in Canada, Australia, and the US. So she's been pretty much everywhere. Of course, she also managed teams here in the US, in Canada, in the UK, India, and China. So now, without further ado, I'm gonna bring Kate on the screen with us so we can say hi to you.
Hello. Thank you very much for your kind introduction.
Oh, we're so excited. You know, I was always very eager to bring people like you on the show because it's just a breath of fresh air to see kind of different backgrounds and also see what you achieved for the open source community over your career when it comes to both safety, real-time OS with Linux, and what you described to me when we prepared this episode was pretty mind-boggling. So I'm pretty excited to be able to share all this with the team. In fact, the first thing I always tell or ask of our guests is to give us a rundown of your journey. So we're gonna let you do that.
Sure, happy to. So I started my career after grad school in IBM, working on optimizing compiler backends, and really liked working down with the hardware and optimizing software for how we can actually get this to be efficient and effective. And that sort of set the tone for a lot of the other things I got involved in from year to year. And at that point in time, I was working on some of the improvements to the scheduler on the IBM Excel compilers. Some of these technologies made their way out to open source later years, but that was sort of the start. After that, spent some time bringing up some of the first PowerPC chips in Austin. I was sent down to Austin on an assignment and to put hands-on in the lab, and again, doing bring up, seeing how things sort of start to come to life from the silicon and how we enable silicon was something I thought was fascinating. One thing led to another, and I eventually ended up moving into Austin and working at Motorola with one other small startup in between. And at Motorola, I was very much involved in the silicon enablement and how we bring up silicon, how we get it effective. So that sort of theme was there, and it was at Motorola I started working with my team. We started working on open source because we needed something that was neutral, and so we could bring up the silicon and do the enablement. And so we were doing BSPs for all sorts of different silicon revs, and Freescale became Motorola became Freescale. We spun out on the semiconductor side, and so we saw a lot of those sorts of perspectives. And I did a bit of a change after that, and so I was Ubuntu's release manager for a couple of years, working for Canonical and managing the Ubuntu distro. So that suddenly gave me a lot more visibility about the community and the power of communities, as well as how you actually make releases happen on regular cadence, on time. And you didn't have to worry about the silicon so much, but you had to worry about community and managing releases. After that, I was at Linaro and doing roadmaps for the ARM ecosystem and working as a product manager there. And after that, I've been here at the Linux Foundation. And so I've been here since 2015. And some of the projects I'll be talking about a little bit more, Zephyr and real-time Linux. One of the first things I saw when I joined that, you understand embedded, okay. And hey, we need to get this real-time Linux stuff actually upstreamed. So I've been working on that project pretty much since the start, as well as Zephyr was one of the embedded OSs I started working with when I joined.
Yeah, and the embedded stuff obviously would be very exciting to the audience here dealing with embedded systems and real-time OS, having to often go to very expensive commercial options. So having the ability now to go straight upstream and get a real-time OS capability with Linux is just mind-boggling, and that's probably been I mean, I would argue one of the biggest piece you brought to the foundation in a very short amount of time. It's pretty exciting to see.
Yeah, the embedded Linux stuff sort of started actually when I was still at Motorola, and we were trying to get it upstream. So I knew it was important for the embedded space to have this stuff upstream. The other piece that from the Freescale days was, trying to share software bill of material information, because we were putting out BSPs and we had to communicate what was actually in them. And we were having to do it for licensing compliance, that we had to actually have all the ingredients listed. And gee, what does that sound like? Kind of sounds like an SBOM. So been working on this sort of thing since about 2009.
Wow.
And the SPDX project is, I was working on it way before I joined the LF, because we kind of needed it for embedded. And then other places started seeing the need for it too. And so more and more use cases got it out over time. And since about 2015, there's been a focus on security and what we need to do for getting security. Because at the end of it, you have these components and they have relationships, and you need to know exactly what you're shipping. And so
yeah,
that's kind of there.
No, that's why I think we're gonna have a lot of fun today, because you're gonna cover a breadth of different topics that the audience really cares about. So that's gonna be a lot of fun. But first, I guess you have a pretty unique title that I've yet to see anywhere, which is pretty exciting. Tell us what it means to be a VP of Dependable Embedded Systems for the Linux Foundation.
Well, I very strongly believe we need to have software be dependable, and dependable in the sense of reliable, maintainable. Security has to be there. We have to be able to take it through safety certification. We need to have software that is there, especially in the embedded space, because sometimes it's so much harder to update and enable, and fix vulnerabilities and so forth. So the updates and so forth motivate us to figure out how we can get it right. And if we can't get it right, what are the effective mitigations we should be looking at? So these pieces all have to come together. And the embedded space cares about some of these things. It has for a long time, a lot more, but maybe a less structured way. But there's been safety certifications, like your autonomous driving. A lot of that is being based off of open source. A lot of containers information. There's a lot of pieces that are moving from things that were not traditionally considered embedded into the embedded space. So what I'm focusing on at the Linux Foundation is open source projects that are being used in the embedded space, and then what we can do to make sure they adopt best practices. And in some cases, we may want to try to take them through formal safety certifications, as well as adopting the best security practices. Things like having a security incident response team for an open source project when there's enough critical mass associated with it. So these are all the pieces that are getting sort of pulled together. And so we want to try to make sure that the embedded software ecosystem is dependable, and especially for the open source projects that are being contributing into it. Because I think the estimate from embedded was Linux was in about 60% of all applications right now. And then there's places where Linux doesn't fit, and we still need it to be embedded, to be dependable. So trying to figure all these aspects out has been the fun challenge.
Yeah, 60% is a lot, and that's pretty amazing. So let's start digging into the subject. And people sometimes struggle to understand what we mean by embedded systems. Can you define it for us?
Well, to me, embedded systems is a system that has some degree of resource constraints, be it power, be it space, memory. Generally, it may be headless, but it may not have a terminal display. It has some sort of fixed function. But for the most part, it is, there's resource constraints you have to work with. Like IoT space is pure embedded, as far as I'm concerned, for the constrained devices. You could argue whether a cell phone is or isn't, but it has fixed functionality. And so the embedded space is, when you don't necessarily have an interface or a terminal, in my mind, for the most part.
Interesting. And do you see edge? So effectively, edge. Most of the edge would be, I guess, anything without a terminal would be also.
Yeah, I'd say the edge is servers that are collecting data. So that's definitely the edge. But then there's all those nice little devices that are connected to it. And so, the edge has constraints potentially about you must, do a certain amount of servicing in real time across all your devices. You must collect the data. So there are constraints there. There's time constraints potentially on the edge servers. On the resource constrained devices on the other side, if you've got a sensor measuring temperature, you're not going to want to spend $100 on it. You're going to want to use a very cheap little sensor, and you're going to want to keep it as small and cheap as possible because you may just throw it away after it's used, or it may ship with something. And so, but that sensor and the data that's coming from that sensor, it may be important to not let someone intercept it. We may need security on the encode, on the communication path between those constrained devices and the edge. And so figuring out what we can do to make sure that options are there and people have, tried and tested options for how they enable these devices, especially when Linux doesn't fit. It's been a main part of my focus.
And do you find maybe that when people are trying to save money, particularly, in some of these use cases you just described, that's where, security goes out of the window?
Yeah. We need to make it easy for security to be built in when people need to know it. A lot of stuff was being done in bare metal. And when you're doing in bare metal, it's hard to sort of standardize all your practices. And so we want to keep so we can get to the size like a bare metal would be, but we have the ability so people can opt in to various, configurations and tried and tested drivers, and then, security encodings and so forth. So what we kind of are looking for is a sort of a standardized set of library functionality, the core kernel, and then libraries around it, or configurations, device drivers, and so forth, that can be put together to make so it's only what you actually need, and you have it configured tightly. And so the project Zephyr that we were referring to earlier started with this as a goal, because Linux doesn't get much smaller than 2 meg these days as an image. And that doesn't work in those really strong, tight, constrained, resource-constrained devices for power reasons. Like, you want your battery life on a small little device to last for a couple of weeks. You don't want to be setting to put it on a charge every night.
Yeah.
Things like that. So there's power as a constraint. There may be, hey,
size.
Something you're going to throw away. You don't want to have a lot of, you don't want to have a big investment beyond a couple cents in it, type of deal.
Right.
So
cattle versus pets, and then for the size, the form factor, Yep.
These are all sort of considerations, and so making it easy for people to just select the configs effectively and build something that's very tightly constrained and has been well tested has been something the Zephyr project has been focusing on since it started. And so
when you think of security for these devices, do you see both the I guess the hardening of the device within itself, or do you also see kind of the traffic ingress egress and the encryption piece and authentication, X509 certificate or whatever mechanism that can be used to authenticate the device? What's kind of the focus? Is it both or
both?
Yeah.
You need all the options here, okay?
Yeah. That's
like
what
I say,
thought.
And this is why, scaling up bare metal is so problematic, is because the landscape these days is so complex. And there are so many different, threat surfaces that are out there that need to be addressed. Some care, some don't care. And then you add in the dimension that you may need to put something into critical infrastructure. So there may be safety considerations and safety use cases that have to be addressed. And so bringing these things together and having a framework to do the analysis effectively is one of the challenges out there. And commercial offerings are out there from various vendors that have been there for a while, and they've gone through this. But we really haven't done this from an open source perspective in a large way outside of some organizations. So we're trying to pilot how we can do this effectively for open source right now.
Do you gather any kind of data at the foundation about the number of IoT devices being produced, or maybe how many devices are seen without any security? Are you tracking kind of any kind of data coming from China or other places? Obviously, a lot of it is coming from China. So
I wish.
yeah,
I wish I had the
know, right?
resources to do that.
Yeah.
There are like there's various analysis firms that have been doing studies along this line, and I found it absolutely fascinating that there's now more IoT devices on this planet than there are people, and we're on our way to 2 times the number of IoT devices to people.
Yeah.
And a lot of them do not necessarily, it's not the use cases that are being put in place. The security isn't as important, or they had it. The thing that they prioritized was time to market rather than locking things down. And these are, economic trade-offs that get happening all the time. And so what we need to try to do is make it easy for security to be built in without a lot of economic add-on. So it just is, okay, turn some options on and you can get a more hardened device, or you can make sure that there's, test suites you can be running, things like that to help with your coverage and robustness.
Yeah, that makes sense. And so part of your job, I guess, is to balance, safety and innovation. And so how do you find it?
So innovation is, do things quickly, fail fast, etc. Safety is, okay, we're going to do a full set of analysis on a component within a wide set of systems. And those two things have different behaviors. A lot of open source up to date has been mostly only focused on the innovation aspect. And so bringing the whole system thinking into it and the software engineering aspects actually into this discussion is going to be key for being able to do the safety properly, because you've got to start thinking system-wide, not just your own component-wide. And that's an interesting shift for people. So we've got a lot of, we're trying different things in different projects. In the Zephyr project, we've got a safety committee, and that safety committee has been, responsible for looking at, say, putting the MISRA guidelines in, and it's going after 61508 certification for the code base, and then it's going to be having, and then getting all the traceability and all the evidence marshaled, so we can actually go through a certification for the kernel. The Zen community, which is a hypervisor, is trying to do something similar. Slightly different variants on some things that they're doing. And then the ELISA community, which is enabling Linux and safety critical applications, is taking and looking at Linux as a component and looking at the processes that are already there. And, what can be used in the argumentation that's reliable. Because when you consider all the server market, 60% of the embedded, but all the supercomputers, there's a very large amount of infrastructure running Linux. In fact, I think it's in the SpaceX rockets as well as the Tesla cars.
SpaceX, definitely, for sure. Yeah.
Yeah, and so we know it's being used in critical applications. The challenge becomes is how do you build the confidence in your analysis that you can know that you have not overlooked something? How do you do the argumentation effectively? And so there's groups of people that are coming together and from various companies talk through these problems. And so including the certification bodies like, Underwriters Limited, as well as, some of the ones in Europe, coming together, looking at the problem, looking at it from various domains and standards and saying, okay, what's relevant, what's not relevant. And I'm kind of excited because we've just got a new one starting up in that group for the aerospace industry. So Boeing just joined the project and they want to start forming a group to start studying aerospace. And so, if people are interested in that area, by all means, feel free to reach out to me on at least about that you're interested. There'll be a talk at our next workshop, for instance, talking about this working group that they want to start forming to look at DO178C and how it interacts.
I'm sure a lot of people here will be interested by that because that's what we do. So that's exciting.
Yeah, so it's the innovations are happening, and it's innovation as well in the analysis. It's not just innovation in the projects, but there's a lot of wealth in open source, and open source is very attractive from an innovation perspective. We just need to put the guardrails and some of the frameworks for doing the analysis around it.
Yeah, and it's interesting you mentioned SpaceX because that's one of the video I made recently to compare SpaceX with F-35. SpaceX being able to do 17,000 build of software a day, effectively, like you said, running Linux upstream on real-time OS, be able to not use hardware specialized in the space industry vacuum. So it's really opening the use of pretty much every commercial open source capabilities. They can do 3 hardware in the loop testing a day, update software a few hours before the launch, and I guess the whole concept of ruthless automation enables them to move faster, right? By automating the hardware in loop testing, the OTDT, and all the assessment we do to make sure that new features on the software are not breaking things. And
Right.
so I think it's just a great case study to look at. And I always get people to say, well, yeah, but they had so many issues, and crashes and things. But people don't realize that none of those were caused by software. So that's not really a valid point. Their velocity has been, at that kind of scale because of the adoption of DevSecOps, backend security, and automation. And that's massively enabled by using traditional CPUs and Linux. The first thing they mentioned to me was the fact that they use upstream Linux. That was the massive enabler for them to use every kind of tool on the planet they want to use. So
it's a very robust ecosystem, and it's been in development for 31 years, and they've figured out some processes that work. And so one of the things that I was doing over the last 5 or 6 years is working with the Zephyr community to figure out what parts we can adopt from their processes. So Zephyr is not Linux, right? But we want to try to have things like having the maintainer hierarchy that Linux sort of pioneered, using the common infrastructure, looking at how you can get, having the LTS concept where something moves fast, which is your development, but you have something you keep stable for building products on. And so that's sort of a very much a clear, innovation happens in the development tree, and then you look at building products from that stable, and that's safety. And so Zephyr has an LTS cycle, the same way the Linux kernel has an LTS cycle, the same way that Yocto or distributions have LTS cycles, or for that matter, Ubuntu has an LTS cycle.
Right.
It's a best practice out there when you're working with things that have elements of safety and security to know, hey, we're not going to keep this one at the bleeding edge. We'll keep it supported, though, for the security side. And then that gives people time to do the analysis that they want to do at system level.
And that you brought up again Ubuntu, I really have to ask you, during your time, helping the team, can you describe, your role during that period? I think you were a release manager, right? So
yeah.
What does that mean for people that don't know what that does?
So my job was to make sure there are 3 factors when you're doing software. You can do time-based releases, you can do feature-based releases, or you can effectively have quality aspects. And what Ubuntu decided to do was focus on the quality and the time. So they had a very predictable cadence, and it came out on a very regular basis. And that still is happening today. And then every 2 years, one of these releases was declared an LTS and had some extra cycles of testing and support going forward. And the support period was articulated up front, so people sort of knew what they were getting into. So my job when I was doing release manager was managing, okay, can we make sure we can hit that date, and making sure that the quality is high enough when we hit that date. So I was working with, the desktop team, the kernel team, security team, lots of, the 0 days, etc. And then a variety of servers, teams, and so forth. And we were trying to basically make sure the code base was coherent and available at a quality level at the date. So new features were being added throughout the release, and then there was a solidification period. So my job was to effectively project manage what was happening and then minimize the risk so that we could ship on time. So once we start getting close to the date, okay, what are the impacts of a feature? What dependencies might this package rely on that if there's a bug will cause us to miss the date? So I started looking a lot at the dependency trees in that period of time, and did a bit of work on, analyzing the seeds and so forth, and figuring out some tools so we could actually sort of understand what was happening, which kind of nicely tied into the whole SBOM and transparency thing in the early days, and having relationships to show that type of stuff.
Yeah, would you argue that having access to an SBOM at the time would have helped you do that kind of dependency tree
Yeah,
nightmare.
yeah. Like I say, when you ship the distro, there's a manifest that goes with it. That just gives you the full list of elements. And as they're generating it, they're going through and creating this information on dependencies. As you're doing a build for pulling this distro together, you've got that information. That we didn't have a good way of how should I making it transparently visible. And so one of the things that's been happening with the whole adoption of SBOMs is we're getting these organizations now looking at taking the information in their build-up structure and then summarizing it out so that it's easier for people. And I think that's going to help the safety aspects as well as security aspects, because you need to understand the transparency of what you depend on, and when someone's building your package, what it may be depending on is important for the safety side as well.
Yeah, no doubt.
Supply chain.
And so, wanted to follow up on the balance, right, of safety innovation. Would you say it would be pretty difficult to succeed at moving fast if you don't embrace kind of that baked in security versus bolted on, and kind of that automation aspect of what DevOps, DevSecOps brings to life? Is it even doable to get at the pace you need to move at to compete without these kind of key principles?
Yeah, no, you need to have security thought up right up front. And like when I was at Ubuntu, there was a security team there that was basically handling all the vulnerabilities across all the packages. And security has to be there right from the start. When we started the Zephyr project off, the first committee we started when we kicked the project off was a security committee to focus on making sure we actually could do the threat modeling. And then, that evolved into the PCERT team. So security has to be there from the start if you want to get to velocity over time.
Yeah, baked in, right? Not bolted on after
Definitely.
the fact. That's always. So now you talked about safety and innovation, but what about safety and security? How is that different?
Well, safety has the aspect of you need to do a full analysis of a system, and you need the components all to be secure for it to work properly. Now, the challenge becomes is what happens when you notice a vulnerability down the road after you've done your analysis. This is where there's sometimes some tension in the sense that does it invalidate your analysis or not? And so understanding what the code is and whether or not if you're applying a bug fix, is it necessary first off? And if it is necessary, does it invalidate your analysis? At this level of analysis, you need to really get down to the source file, and you need to be able to traceability from the binaries all the way down to the source file. And so getting us to the stage where we can actually have for each built binary full traceability to the exact source files that make it in is, I think, where we're going to need to go for security and true automation for security. We've actually done this at the Zephyr project. All you'd have to do is change say West SPDX, which is the build tool there, and then do your regular build, and you will automatically get 3 SBOMs generated, 2 source, and then one build SBOM that links back to those sources. And so that is an example of, I think, where we need to be going from a security and a safety perspective, so that we can actually make the right trade-offs of, hey, this vulnerability affects this type of stack that's built into this package. Am I even invoking it? Have I configured it to be included? If I haven't configured it to be included, even though it's in the package version, it doesn't matter. It's not included. So we need to be able to be explicit about what's there, and the transparency and the ability for the traceability down to that level is going to be key for us to get this working effectively. So Zephyr's doing it. The other project that's embedded that's doing it is Yocto. And so Yocto's builds, it's a distro builder. And what it does is it will build the cross tool chain, and then that cross tool chain will build your executable. And for the cross tool chain, the recipes will generate out an SBOM. For the built executable, you've got an SBOM, and then you've got the relationships between all these elements, so you can understand what's really there in your supply chain. So these sorts of things are there today, and to turn that on in Yocto, it's again, you change a line in the config file, and that turns it on. And so having this stuff in the background and automatically generated is pretty much where I'm we need to be going for the security side as well as for the being able to do the safety analysis properly.
Yeah, no, absolutely. Do you find when you look at, I'm sure you get to see a lot of different use cases and looking at different projects and different teams. What keeps you up at night looking at some of these? Do you feel like we're doing pretty good? Do you feel like we're still way too far behind to where you want to be in terms of that safety / security component? Are we finally waking up a little bit because of the executive order? I mean, I see some movement, right? Some progress, but I would argue it's still pretty anecdotal.
Well,
What's your take on that?
So I think the transparency and the transparency of the software you're running on the systems. What keeps me up at night is, I want to have, in 10 years' time, if I have a self-driving car, I want to have trust in it. Okay, because I'm sitting there, right?
Yeah.
And it's using AI algorithms to figure out where it needs to go and to not hurt anyone on the way and not hurt me on the way. That's where safety critical comes into, right? Person, it could have much harm something.
Yeah.
And keeping the AI information and the training data, some of those use cases, and we don't have good ways of describing it right now. Like in the SPDX project or Software Package Exchange project, we're busy looking. There's a group of us looking at that, and so we're looking at how we summarize the data set information and how we summarize the trained model information, and how we can sort of pull this stuff together so we have that visibility. But getting that visibility and the transparency so we can debug problems as well as record them, as well as, quite frankly, do the right level of analysis so all the artifacts can just get generated and linked. This is areas where we're busy working on extending the current specifications and standards for. So when the NTIA work happened, the term SBOM really wasn't much out there. we were using it in various other places, in these places, and from a hardware side, we always had the concept of a bill of materials or a BOM. And the software bill of materials is something that the OpenChain project started advocating we needed to be having, and when we're working from one vendor to a next. And so the processes around working with software is what OpenChain was figuring out. And one of the key lines in there, it's a very short spec. It's an ISO standard as well, but it expects you there to be a bill of materials for your software. And that's what you're communicating from the licensing and compliance perspective. And funnily enough, if you've got that level of information, you can use it for the security stuff too. So having that transparency is kind of key. However, there's a lot of concepts in machine learning, in doing the builds, the pedigree provenance, in taking these next steps that we don't have good ways of modeling right now and sharing the information. And so what the SPDX team is busy working on is there's working groups in there. They're focusing on the build information, the usage information. When does something go end of life? When we were doing Ubuntu, we knew what the end of life was for things. Okay, why aren't we communicating the end of life information with the software? So hey, if you're running an auto check on all your software on your system, if something's coming up for end of life, maybe you might want to do some risk analysis proactively and decide, are you going to do an update or not? So
even the release day was helpful to me because I would look at how quickly vendors are releasing or updating the dependencies. Too often I see people say, oh, we have all these CVEs, but it's not in the code path, right? That's a magical term, although no one can really verify that because, often we don't have access to the source code, so we don't know what's going on. And so having the ability to see first, okay, is there some kind of hygiene when it comes to updating dependencies? Are we really stacking time, which will lead us to this end-of-life problem, right?
Very much so. The hygiene aspect and understanding if it's in the code path is the reason we start to need to have the visibility, especially in the critical infrastructure, down to the source level. And the standards have always called for that. We just need to have a way to be automated because we can't scale manually. We need to have this stuff at our fingertips, right? So keeping this stuff available and having the analysis there is pretty much, I think, for us to get where we need to go at scale. And the industry is moving so fast and there's so much innovation. It's exciting, but the things that keep me up at night are, okay, are we keeping the transparency up with the software? What we're depending on.
And so do you see progress being made in terms of like at least the awareness, and like did you feel maybe also Congress should start thinking about some type of law when it comes to companies that often gets away, they get away again and again, sometimes with 0 days and tremendous levels of CVEs, and no one cares. And is there a gap in some type of enforcement function that the government could do, or is that the wrong answer?
I think what the Biden administration did with the executive order last year was probably the most effective way, which is making it such that you can't sell to the government unless you provide an SBOM. That has been a tremendous motivator for a lot of tooling to come into play, a lot of new business cases and companies to come into play. And so being able to, so we can get this information there and get it consumed, there's a lot of innovation happening in this space, and getting that that lingua franca and that language for communicating this information so the tools can consume it to do the next level of analysis is certainly part of the challenge. Like one of the tools that just emerged in the last year came out from the NTIA healthcare proof of concept, where New York Presbyterian Hospital, during all the COVID stuff, their IT department basically created a tool to consume SBOMs and then match them up to the vulnerability database and have a dashboard. And that's now all open source. And so this is the first time they actually ever open source and participate in open source. But the fact that they did this work during that period of time and then made it available to other small hospitals to use, and it's not really specific to a hospital. Any small business could go and use the Dagger board stuff, set it up, and monitor the software they've got if they've got the SBOMs feeding.
So it's kind of a management. Is that a kind of a management of SBOMs? Is that what it is?
Yeah, it's basically, we've got a lot of management systems and asset management systems and so forth, and hooking these concepts of SBOMs into your asset management and knowing what's actually on your system is key. The components are certainly the first level, but if you're going into the safety space, you probably want to go down another level, down to the source levels, etc.
Right.
Just to have that confidence and making it easy to go to whatever level's appropriate for your application, I think is part of the challenge here for us.
Yeah, no doubt. So in fact, we're going to talk a little bit about how does SBOM end up working, right, in that embedded space. So embedded space obviously is a little bit unique, right? You have all the constraints we talked about, and the hardware piece of that, and the form factor and cost and all the good stuff. What's different when people think of SBOM specific to the embedded space?
So I think what's different in the embedded space is some of the challenges in the other spaces are a little bit more intense, probably. You want it so that it just happens in the background. You don't have to think about it. And you want it as a sidecar. You don't necessarily want to embed any image because you've got such resource constraints, usually for the space reasons. And so having the information there, and such that anytime you just do a build and do your test runs, etc., once you've done your test runs, you've got your SBOM there, you're good to release it. And when you're releasing a binary, there's always an SBOM with it. Getting us to that stage in the wider ecosystem with the whole plethora of embedded tools and embedded ecosystem is a good challenge. We're showing a couple places that I've talked about where we're doing it, but there's so many more. The open source software ecosystem is tremendously wide. And then there's a commercial, which builds on top of the open source ecosystem. And so getting it so that we can get these things happening in a sort of standardized way in languages such that tools can consume it and keep on top of it is the challenge right now. When we talk about the concept of Christmas, our Christmas presents from the security space, right? Where we get vulnerabilities just before Christmas. It might be kind of nice such that, in a year or two's time, okay, we hear that there's a new vulnerability. We just basically do a query on a database, and that's inside our company, and know yes or no, I'm affected or not. And if I am affected, I know exactly where. So where in the database through the dependency trees, as well as potentially, a stack that might be embedded, what I might have to do to remediate. So a lot of people suddenly would not have to spend their Christmas holidays going through code to double check all the pieces. I think that's a win for all of us. And getting us to that stage where we can just make that a reality is something that, a lot of us are really trying for.
Absolutely. Adam was asking something that I actually have been pushing or promoting for many years, so I'm biased. But he's asking, what's your thoughts on whether digital signatures should be required? I'm going to say for
Yeah.
SBOMs.
So inside a lot of the SBOM formats, you have hashes already for the object, so you know whether or not what you're describing has changed. And so I'm a strong believer in that. And then you have the signing of the SBOM itself.
Right.
And
is that required? I mean, it's not required though. I don't see everybody do that.
Well,
too,
I think it's a best practice. I think you're going to see and make it easy for people that when you sign that this SBOM is related and to this binary, and have someone attesting that these two things match together. Yeah, I think
right.
we're going to need to go to that.
And it should be. I don't see how we get away without making it a requirement. I don't think that's a maybe.
Well, again, like you say, it's not always a requirement that you care about enabling some of the security features, right? It all depends on the context. So some of the challenge here is like one of the Project SigStore that's out of the OpenSSF group in the Linux Foundation is very much focused on making it really easy to generate these signatures.
Right.
And then figuring out these tool flows.
We use it in DoD, by the way.
Okay, excellent. And figure out how these tool flows all work so that this stuff just happens automatically in the background without thinking about it. And the information is there. That's where we need to go.
And so I guess at the very least, you're thinking, knowing the provenance and not just the integrity, right? But the provenance with the signature is kind of what this brings to the table, is making sure that it's coming from the source it's supposed to be coming from, right?
Yeah, and it's when we were shipping out the Ubuntu images, the images were all signed. There was a signing authority that worked. I mean, you could use...
You wouldn't see Ubuntu release without signing, right? I don't think that would be a thing.
Exactly.
Right.
And so, you really don't want to... you want to put some... there's different ways of communicating the embedded information and so forth. And so having the signatures is going to be very appropriate in a lot of cases. So I think I think there's aspects of, I'm just doing my little hack project. I'm not going to put a signature on it because I'm just going to use it myself. So it's
sure. But the minute I guess something becomes mature enough, right? I mean, a decent size open source project or commercial project, that should be. I mean, that's just an expectation.
I think it should be an expectation. I think it's a best practice that there's mechanisms available. Certainly, anytime money changes hands or there's contracts involved, definitely it's worth thinking about here. And quite frankly, you're going to be using it as a risk analysis, right?
Right, if they don't have it.
Running software, it's a risk factor. The same way, if you don't know exactly what's in your SBOM or what's in the software you're running, you don't have an SBOM, that's a risk factor.
Yeah, I don't know if I would accept an SBOM on the government side if I don't see a signature. I can tell you that. I just feel like
I say, and so this type of thing is going to motivate the change that we need to see in the ecosystem to make it easy for everyone.
Pushing people up, pulling up the work. Yeah, that makes sense. So let's see. You mentioned, someone was asking, because you mentioned generating code for security. What's your thoughts on the state of the art there? Is it still barely scratching the surface, or where are we on that side of the house, I guess?
I guess generating for security is a rather broad term in my mind. So I'm trying to... So what we're doing a lot of work is generating the SBOMs automatically and focusing on doing that so we have that transparency, traceability of what's there. And that's maturing nicely, I think, on the generation side. The consumption side still needs to have some work done. In terms of the algorithms, well, I think there's more algorithms coming up every day for the secure communication channels and so forth. I think we've got a fair amount there, and I think we're roughly... And it's like, on the other hand, a lot of us are still using SHA-1s as opposed to SHA-256s or other things. So I think there's work to be done there. But again, it's a risk analysis that has to happen. One of the things I think is really exciting is there's a project called Best Practices Badge under OpenSSF. It used to be under the Core Infrastructure Initiative. It's moved under the OpenSSF Foundation right now. And what it does is it lets open source projects publicly attest to the practices and policies they're following. And one of the things we're trying to do in some of the embedded projects I work with is making sure we get to the fact that they are passing and they're using good practices and hygiene. And so having this stuff visible and public, as opposed to trying to dig through random emails to try to understand this, helps bring confidence. And so seeing one of the things we were sort of proud of with Zephyr is, well, actually this badging practices started when Zephyr started. And so as we were looking for good security things, we started looking, okay, let's go see what's happening there. And so over the first year or so, we actually worked our way up to a passing badge in the Zephyr project because we were focused on it. And it wasn't that hard. It was just things you have to do and thinking about it. And then they added a silver and gold level. And Zephyr actually managed to make its way up to the gold level. And I think there's only 5 other ones up there. I think there's about 12 now. And the Linux, we got there before the Linux kernel did. They were closer longer than we were, but we got up there quickly. And so the Linux kernel is there, and then Zephyr's there, and because a lot of people depend on these types of code. So having those security practices and are listed in there, and some of that is using things like the fuzzing tools, using the static analysis, actually understanding where the vulnerabilities can actually come in. So
I would argue it's all pretty reasonable stuff. I don't see like crazy nonsense like some of the government contracts asking for your DNA. That's pretty basic stuff, right?
Yeah, we sort of went through it, and then I was just sort of going, okay, rub down, and then all of a sudden we started failing, and they'd been checking our web links, and we had changed some of our infrastructure, and it picked it up on us, and so we had to go and do our 2-hour updates on our documented process, and we're probably due for another set of updates actually, but the fact that there's some cross checks there and that there's some public criteria and people can, reach out and say, hey, I don't think this is what it's doing. You've got a way of saying and asserting what your policies are. Having this type of badging available for open source projects, again, helps with trust and helps with making sure they're following the best security practices that are known out there.
Yeah. People were asking, what's the difference between OpenSSF and the Linux Foundation?
So OpenSSF is a foundation, the Linux Foundation, and it's hosted under the Linux Foundation. It has separate governance. So there's different governing boards for each of them, and those governing boards control the fundings for each of these projects. The Linux Foundation doesn't dictate what the OpenSSF is going to do. It's that governing board that figures out where it's going to go. So what OpenSSF's mission is improving security across the open source ecosystem.
Can you remind people what OpenSSF stands for people that don't know?
Yeah. Open Source Security Foundation.
Here we go. That was always a good first step.
Yeah, and what the members are focused in there is improving the security across the wider ecosystem. That is this project's mission.
And it's not just for Linux.
No, it's not just for Linux. It's for all software. And so, the tools that are being generated there to be working with open source software, there's no reason they can't be used, with proprietary software as well. And so going through some of these checklists, using some of these tools, working with, the scorecarding, all of this is, trying to get a handle on what my risk is of using this code and what is its life cycle going to be. And then the SBOM sort of relate into that. One of the things I'm excited about personally and participating on there is there's an SBOM everywhere special interest group that's formed up, and it's formed up under the tooling. And what we're trying to do is make sure we can help reduce the barriers for SBOM adoption and making it easy for companies to take and consume and produce, as well as build on these SBOM formats. So there's a group of people that are meeting in that group. The other thing I'm excited about is CISA is starting up their working groups. Alan Friedman was doing a lot of the work on SBOM at NTIA and has moved to CISA now. And those groups are going to be starting up as well. And that was an effective forum for collaboration, I thought, for the last few years. So, getting these consensus from the industry as to what's reasonable built up is one way of making sure that whatever guidance comes down from governments and organizations, international as well as domestic, is implementable and reasonable. And then hopefully by that point in time, the people who are participating at the forefront edge are just ready to go. They've done it already. Once we catch up with what's being required. So thinking forward and making sure that the best practices are adopted and evolved helps, I think, the whole ecosystem.
That's great. So back to the embedded space and SBOM. How do you get this done, right? Because it's always easy to talk about stuff. I'm pretty good at talking about stuff too, but how do we get it operationalized?
Well, we get it operationalized for the most part in the tools. I'd say there's 4 types of SBOMs. I consider them anyhow. One is a source, where you basically got a source. You're just summarizing all the source pieces that are there together. What the licensing is, what's a potential pool to build binaries from, things like that. Then you've been given a binary. You want to do your binary analysis on that. What can I discover about what's actually in there? Because no one's going to tell me what's in there. I need to do my own risk analysis, right? So there's a binary.
That's always pretty tough, right? That's not
easy.
That
one's pretty tough because you're doing forensics and detective work for the most part. So I probably have the least trust in that. The one I probably would have more trust in is the one you're doing when you're building. So I think the operationalizing is every time you do a build, like you run your
compiler. It's between the source and the binary, right? It's in the middle, right there.
It's between the sources and the binary. So you have that full traceability of what made it into that final library and which libraries made it into that final executable image. So the build. So I call that one a build SBOM. And then the 4th type of SBOM is sometimes called runtime or deployed, which is what configurations were turned on when this image started running in production for me. So this is all part of the configuration side, because quite frankly, if you've configured it a certain way, you may not be vulnerable to issues.
Right. Or you could disable, or the opposite. You could disable a crypto and now be vulnerable.
Right. It's all, it's running too slow. Therefore, I'm going to disable this crypto. Yeah, maybe not such a good choice. Just depends on the situation. So
it's interesting. The source SBOM you described, right? I never thought of it. Funny enough, I always thought of the build, the build phase. How is that? I mean, is it just effectively pre-built? So it's all scanning the source code and just looking for dependencies, purely looking at the Git repo, I guess?
Yeah, I'd say it's looking at the sources and it's summarizing the sources that then get used in the build. And so this is part of like when I was talking about the Zephyr, and we have the 3 SBOMs. We have 2 sources, one for the Zephyr sources, one for the app sources, and then one for the build. And then the third one is the build. And what the build is it says this .o, this .o, this .o made it into this library, and this library, and this .o made it into my ELF image that got loaded onto a machine. Right? And having that traceability for the .os that made it into that final image, and then linking those .os back to the sources they came from, gives you that level of transparency we're going to need. So you need the sources, you need the build SBOMs for really getting automation to happen at scale. Otherwise, you're still having a lot of manual there. Like what brought this one home to me personally was when the FNet Amnesia 33 came out, right? A couple years ago. And Zephyr had the right FNet component in it, in its LTS version. However, when you actually look down at the source files, none of the stack that was impacted was actually in the Zephyr binary, in the Zephyr repo. It was at the source file level we knew that it was clean. But we had no way of signaling this. And so we ended up having to put a blog post out to say, hey, no, we're not affected. It's all good. But this is part of the reason I'm also a really big believer in the whole concept of vulnerability exploitability exchange, or VEX type of information, or advisories, so that we have ways of signaling automatically when someone's done the analysis. Can I share this analysis with someone else? And hey, I've done this analysis on Zephyr. I can put a VEX out saying we're good.
So can you tell people a little bit about VEX? For people that don't know.
Sure. VEX is some work that sort of spun out of the NTI SBOM work, which is and it's vulnerability exploitability exchange or expression. I'm never quite sure what the X stands for sometimes. But the idea is you can say whether or not a vulnerability impacts something or not. And you have a way of summarizing that information. And so the CSAF group, Common Security Advisory Framework work that Oasis has been doing, they've been working on, they created a VEX profile in conjunction with the NTIA work. And they said these things can be used to signal whether or not a piece of code is vulnerable or not. And so that is sort of where it's been going. And so building it up for having ways that we can automatically share vulnerability information, which happens after the builds, right? After the build of the SBOM. It may happen after you've configured and deployed it too, but having the way of saying, we noticed this, and how do we start looking and saying whether we're affected or not, having a way of communicating that between multiple parties, that's what the VEX stuff is letting you do. So, the common examples being, a company has a product out in the field, and they want to tell people, you heard this vulnerability on the news over here? You're not affected. We've checked, we've done the checking, as opposed to, yes, you're going to have to go do this update. So having that effective communication is going to help the system scale as well.
And do you so I guess it's Exchange, the last.
Thank you.
And do you see it used to share publicly the information, or do you see people being able to use it to share just to their customers, or how control is the sharing, I guess?
Completely up to the organization. Okay.
What do you recommend people?
For open source projects, I recommend being completely transparent.
Right. It's kind
okay.
of
For commercial projects that have brought in pieces, making sure that responsible disclosure happens. And so some of this may be a value-added story that they give to their to their customers, right?
Mm-hmm.
That they say, hey, you're buying support from us, therefore we will be sending you this type of information. And we don't want to get in the way of their business cases, because we need it all to work effectively for everyone.
What do you tell people that one of the pushback I had when I was pushing companies before the executive order to give us SBOMs was the fact that companies refused to share the SBOM and the CVs with us, for risk of whatever they felt like was dangerous to them, or whatever, kind of putting their head in the sand, hoping for the best, right? What do you tell people to convince them that participating and sharing SBOM is the right way to do business, I guess?
Well, I think we had a lot of this sort of discussion in the NTIA group, and there's a fact that we ended up creating. And the best way of explaining this is, the attackers already know this information. They can go and do the right, have the tools to go and look this. An SBOM is effectively a roadmap for the defender. To figure out what you need to do. It's not a roadmap for the attacker, it's a roadmap for the defender to actually be able to figure this out and decide, do I need to work on something or not.
But for some reason, some people believe no one has access to their products, right? So it's so closely guarded that the release is, but that's a pipe dream, right? It's just
a pipe dream. Like, as soon as you're running something, someone could put a sniffer on it and look at the
it could be a malware getting access to a server, it could be whatever server compromised and people exfiltrating the binaries or whatever, right? It could be.
Right. Yeah. So I think we've got a lot of, like one of the things I was hearing as a piece of FUD was, oh, you can't do an SBOM for firmware. So this is where something like Zephyr just basically proves no, you can.
Right.
In fact,
you guys do that.
Because we're doing it today. It's possible. For C languages, yes, you can do it. You just put it.
So why are they saying it's not possible? I never heard that one. In fact, wait, before you skip, that was my next question. You're cheating here. So let's dig into it. What about firmware? Why are people saying it's because of the nature of firmware? They're saying it's not even feasible.
Yeah, that's what I was hearing a lot of, which is because
why are they? What's the logic behind? I mean, I'm sure they must have an argument somewhere.
I think it was more along the lines of they just didn't see how to do it.
Oh, I see.
Okay, and hey, I'm compiling a binary. It doesn't have all the hooks that this package manager would give me. Therefore, how can it be possible? Well, it's possible because you stick it into the build, and you've got debug information when you're assembling and linking an executable together. You've got the information there. Remember, I started my career off as a compiler geek. Okay.
Yeah, that's what you do.
And so linkers are important to pull all the pieces together, and they've got a lot of this debug information sitting there, and we just need to export it in an effective form, in a common form that people, different tools can use it differently.
So they can do it in source, they can do the source, and they can do the build, right?
Yeah. And that's what the Zephyr project is showing right now. And in fact, one of the ways we're showing it is there's actually a dashboard that Antmicro, who has simulators, did. There's over 300 boards on this dashboard and about 5 different applications, including one using TensorFlow Lite for machine learning, okay? And for anything that's showing build and pass on that dashboard, if you download that image you could load it onto the hardware and it would run. But if you download the image, or you can on the simulator and run for that matter, it's got 3 SBOMs in it. And it's just happening automatically across that whole space. And that's the level. And they were doing that because they could just, change a config option and it would just start happening. And so those are all firmware images. They're all alpha images, and they all have SBOMs. And so there's over 1,000 at least plus in that little dashboard that gets rerun it gets rebuilt every day or 2 days or something like that.
So that's where automation is key again. And so the project, of course, had to build a bunch of software, I guess, to end up creating this automation. Is that accessible to other firmware companies that would want to use that to just do their own SBOM?
Yeah. So the work that was done for the SPDX project is in the West tool, and that calls into the CMake infrastructure. So there's been hacks, there's been changes put into the CMake infrastructure such that when these options are turned on, it gets generated. The other place you can look for examples, again, all open source. So you can go to Zephyr repo and look through some of the CMake build information. You can find some of the hooks there, and the pull request that added it in. Other place was like in the Octo project. And so the Octo project, all its stuff is open, and the recipes and how it basically mines the debug information that's happening as part of the builds and compiles to create this level of detail and relationships.
Yeah, and we talked about Zephyr a lot. Just to give the elevator pitch about why you guys created it, effectively competing to Linux, right? In a sense, somehow, a little bit. Right?
We filled a gap that Linux didn't fit. It's kind of
yeah.
Linux, like I say, Linux doesn't get smaller than 2 meg, and we need things that were 10
it's too big, right? It's just a size thing.
It was a size thing, and we sort of took lessons from it. And
we couldn't have fixed Linux to make it smaller. We had to create something.
This was interesting. I was at Linaro. We were trying for several years, and Nicholas Petra was one of these brilliant programmers, and was getting into the compiler hacking, getting into other things, and he really just couldn't get below a certain point in time, a certain size. And it started off something would fit on a floppy. But then there's been use cases over all these years that have evolved Linux, and so it can get smaller than about the last number I heard was about 2 meg. And you also consider
what's the smallest for Zephyr, I guess?
Zephyr, you can get a small, very small image that's sort of in the tens of K.
Oh wow.
Okay, but like I say, if you put a Bluetooth stack, that's going to add something. If you put on certain crypto algorithms and so forth, you put on what you need.
It's modular. Yeah,
it's very, very modular, very, very flexible, and there's a lot of components with Zephyr that have already been tested with Zephyr. It's kernel, so it's a system more than just a kernel for the real time.
And companies, big companies use it now for their IoT devices.
Yeah, one example, one of our members in the project is Oticon, and so all of the new generation of hearing aids, for instance, especially the ones with the tinnitus control from Oticon, are all running Zephyr. And then you're also, in fact, you're seeing Google will be moving their next generation of Chromebooks for the keyboard and mouse control stuff will be handled with Zephyr. And so they've been public about that. We know there's wind turbines out there with Zephyrs inside the sensors, and working with helping because energy is a consideration there. So, Vestas has got wind turbines. We've got a variety of other options. So there's little tags to know where you are location-wise, or you're in proximity. Those are running Zephyr. There's ear tags for wildlife from reindeers up in the thing I know is running Zephyr. They basically are running Zephyr with a remote modem. And this became economically feasible, which I thought was fascinating because for wildlife management, if a wolf takes down a reindeer up there, the government will reimburse the reindeer, the herder.
Right.
And so it became worthwhile to put these tags on to know whether or not the deer are moving or they're stationary.
How many are getting, Yeah.
And
so you get your refund.
Yeah, exactly. So, there's different ways of using it, but, for wildlife management and things like that, tagging and monitoring, temperature as something tracks through the supply chain is kind of key for certain, vaccines and things like that. So, we've got, devices out there doing that today. So
do you see bigger use like space or automotive stuff? Or
Oh yeah, there's a lot of interest in using Zephyr for some of the sensor management. And in fact, one of the projects we're working on in ELISA is creating a system where we have Zephyr, a hypervisor, and Linux, all working on an automotive application for monitoring a sensor and then still having some of the control stuff. And so we're prototyping how we can look at the system and then do the safety analysis on that. And we're using these components together.
How is that funded, I guess, this project?
The ELISA project is funded by our members. So you can join in, but anyone can join in. So you don't need to be a member, but it helps to fund the infrastructure if people are members. The same way with the Zephyr project. Anyone can see the code, source code, can contribute upstream, whatever. But thanks to our members, we're able to provide the infrastructure for the testing, the CI loops, resources in that way. So we've got like Bluetooth testing is something you want to do for Zephyr. And so there's people that are, there's organizations contracted to do our testing for Bluetooth because it's got a lot of specialized equipment. And so the project pays for that to keep it up to date. And,
and you talked about the, sorry, I didn't mean to cut you off. The firmware CMake kind of change you had to make to generate the, the SBOM. Is that upstream back to CMake, or is that a?
It's within the Zephyr project. We haven't had we've not had good discussions with this. Like I said, we haven't reached out and hooked into the CMake people and see if they want to pick some of this stuff up and adapt it to more general. I'd certainly welcome.
That could see a lot of other use cases, right? That could be almost its own project.
Well, and certainly anyone who's ever interested in talking about this, please reach out. And happy to discuss this with anyone that's sort of working on some of these upstream projects and wants to help generate this stuff automatically. Love to have that discussion and how we can do it with the SPDX format in particular.
Yeah, because it creates a lot of headache, I guess, for you guys to have to maintain this with CMake also doing their own releases, and so being
it's pretty lightweight on top of the CMake stuff. It's pretty lightweight. It's just literally exporting a few things and printing some things that weren't there before. And so you're looking at your values, and then if they change things dramatically, it might change. But getting into the CMake infrastructure is definitely something to look at, as well as all the package managers that are out there, making sure that they're generating this stuff in a way that other tools can consume it.
So you mentioned OpenChain, right? What is it, and how does that relate to SPDX?
Sure. Well, OpenChain is an ISO standard. And it started from community grassroots effort, like SPDX did. And what it is the processes. So here's how I've got software coming into my organization, and what should I expect from the person who's giving me the software? And are the people trained to understand the open source part of it? Are they trained to generate an SBOM? This is a set of processes, and it's you can do a self-assessment. They've got a free self-assessment to whether or not you're compliant or not. So anyone can go and look at the questions and see how they answer, or you can also have third-party audits you too. That option is out there. But OpenChain it's a very short standard. It's about 10 pages, and it just sort of says these are the processes. But it's also got a lot of rich training material on how to work with open source, how to do the compliance stuff properly, and that's all free. And so the OpenChain project has been adopted pretty much worldwide at this point in time. A lot of the major companies are already compliant or quietly working behind the scenes to become compliant with it. And so it became an ISO standard in 2020. And and if you go to the website for OpenChain, you can see all the companies that are compliant with it right now and should be able to provide the evidence you're looking for if you work with them, because they know how to work with open source properly. And they've got a way of attesting to that. Now, when they generate an SBOM, it needs some way to communicate that information. That's where SPDX comes in. It's a language or a format to generate out that bill of materials. And underlying SPDX, there's actually a data model. So there's a lot of rigor behind this specification. And what that data model lets us do is generate things out in JSON in XML.
It's not just XML, right? Thank God.
Not just XML, and in tag value, and quite frankly, spreadsheets. We can actually put the data into a spreadsheet.
You need it in Excel.
And there's like the free tools up there, and I know a lot of lawyers that prefer to see summaries of information in spreadsheets, and so it's pretty easy to do that for them too. And so these are the sort of the formats that are there. It's easy enough to add another format. You just need someone who's really is motivated to do the work of serializing the model into that format. But we've got, like I say, we've got the JSON, and that tends to be fairly good for interacting with a lot of the other ecosystems. And we're also evolving this spec. So we started with the 2.2 NTIA's, the document put out by NTIA as to what an SBOM is recognizes the SPDX 2.2 is a valid SBOM format, and we can describe what we need to do there. We can describe the known unknowns. We can describe, the relationships. In fact, SPDX is much richer in terms of some of the relationships than that was calling for. And so we've got this way of communicating this type of information, and it's a language effectively. And so OpenChain is looking for an SBOM. SPDX is a way of satisfying that SBOM and generating that SBOM and sharing it. So an SPDX is, we put it out under ISO, so it's an ISO standard as well. And we went through the whole effort of doing the internationalization and making sure that it was coherent for that. So it's a formal ISO standard, but it's also a public ISO standard. So you can go to the ISO site, you can find SPDX there, and there's a link to the public site. So you can go and download it without spending money. Because we felt that was really important for the open source community. So both OpenChain and SPDX are public standards, so that they are available. And the open source community does not need to, I'm a hobbyist, okay? I don't really want to spend $5,000 to actually look at a safety standard. On the other hand, right now I have no choice. And this is a barrier for safety and security when you don't have these public standards available. Right. And these things need to change over time. And it needs to be, it needs to be effective and economic. But we need to, if we want the open source community to adopt these things, they need to be accessible to the community in some fashion. And so one of the, the paywall barrier is a factor for the standards in some ways. And that's one of the things we made sure for both OpenChain and SPDX we didn't have. The other thing too is in both projects we have active communities that are continuing to evolve the specifications. There's work going on in OpenChain for more security-related information and how to work with security processes. And in SPDX, we just finished putting out the 2.3 release of SPDX that has a whole new annex on how to handle security cases and using SPDX to handle the security cases. So we're continuing to sort of evolve it, and we added things to interoperate with the CycloneDX spec, and SWID, so forth. So we're trying, continuing to try to make it a good piece of glue to put things together with. And so 3.0 is our next release for SPDX, and you've been hearing me talk about some of the new profiles that will be showing up there. So maybe in a year's time, I can come back on and tell you all about the profiles and how they're being used.
Yeah, it would be great. In fact, tell us a little bit about, the difference between CycloneDX and SPDX, and who is going to win the fight, or is there going to be someone, or both of them will be winning, and everybody will be happy, or do we need one to win, or does it matter? And what's the difference really between the two?
I think the key difference between them is CycloneDX is very much focused at just a component level and for the build flow, and SPDX can handle those, but it also handles a wider range of use cases down to the source level, or quite frankly, into the snippet level. How many times have you heard of a vulnerability that's been copied off of one of those public forum into someone's code base? And, well, it was happening for licensing reasons anyhow, but if you know that this snippet has been copied from Reddit over to here, and you want to annotate it, you have a way of doing it in SPDX. And so you can actually pattern match this stuff and look for it from that perspective. So, and going back down to that source level is something that we...
So SPDX is just better.
Well, I'm biased. Okay?
You are.
I have to admit it, but
I kind of agree, but you're biased like me, but I mean, that's okay.
We actually did, we went to the effort of taking it to being an ISO standard and going through the overhead of doing that and the public review. So that has to say something, I think.
That's a nightmare. That's a nightmare, right? That's a lot of work.
Yeah. And so we've been, we're continuing to evolve it though. And we are not perfect in many ways. There's a lot of interesting use cases that I think CycloneDX is an interesting way of handling, and we'll probably take and
CycloneDX it's pushed by a company, right? It's not a foundation. Oh, I forgot who is behind the.
So I think ServiceNow is the main one behind CycloneDX, as well as I think Sonatype. I think those are the two big companies there behind it. However, it's part of the OWASP Foundation, so it's part of a foundation.
So it's part of the OWASP Foundation.
It's got governance. So, interacting and interoperability is one of the things we are trying to do between the two projects. Is making sure that.
Why do we even need two? Why can't we convince everybody to just do one? They're just egos or silos or whatever. Like it's like DoD, which is not invented here concept things.
Yeah, I think people want to innovate in their own way. And I think we can learn more from having some competition than having none.
I mean, it doesn't hurt to have some competition, right?
Yeah,
that's good.
I think it makes us all move faster. So it's like I say they've got some really smart people in the CycloneDX community, and I think they've got some great ideas, and I think we've got some good ideas on the SPDX side too. So I think we'll just continue to bounce off of each other and innovate for a while.
Yeah, no doubt. So a couple of questions from the public before we let you go, because we've been abusing of your time, but there's been a lot of great information that you gave us today. So we're pretty excited. You mentioned at some point, the Boeing thing and the fact that they're creating some type of group, right? Sibila is working for Microsoft, but she's wondering if she could join without if the company is already a member, already getting engaged. Can they also just join, and how to do that?
They can, like I say, as long as, Microsoft is a very active member, actually, of both SPDX and OpenChain. And so I think if she wants to, we'd welcome, all contributors are definitely welcome. If she wants to talk to someone inside Microsoft first, I encourage her to talk to like William Bartholomew, who's handling the core for SPX3, and then Adrian, who's doing a lot of work with the defects. So there's people inside Microsoft you could talk to who are very active and engaged and can help them find the best path. But if your company isn't a member of the Linux Foundation or of one of these projects, please join us too. It's one of the reasons we sort of did our governance structure the way we did is, you'll notice when I was at Freescale, we started it. I kept working on it while I was at Ubuntu. I kept working on it while I was at Linara, and I kept working on it at the LF. This was not started at the LF. This is all done volunteer from the community.
Yeah, it's not tied to your job.
It's not tied to the job, exactly. So it's very much open community, and anyone is welcome to just join in the meetings and join on the mail list. The mail lists are open too. Yeah.
Do you still do that mailing list? Is it still how life works in the no chat, no Slack, or is it moving to like more modern, I guess, options?
Well, there are Slacks and chats and things like that, and we've got some, but I think a lot of the
it's still mailing list. It's still hardcore.
We still have hardcore mailing lists. We also are doing a lot of work in our GitHub repos these days.
Yeah.
So specification, there's a lot of discussion back and forth on some of the pull requests, so you can find things out.
So you have to go into pull requests. Yeah, that makes it fun.
We've got Gitter as well. We tend to do a lot of work with our Google Summer of Code students there. And so if people are working on tooling, that tends to be very effective. But sometimes when you're actually having those deeper conversations, you want to be able to have the historical context very much there. And you don't want it to suddenly disappear when you exceeded 10,000 messages on Slack for what the free services provides us. So we're still in, like I said, we've got 10 years of mail history, and it's still been serving us reasonably well.
Yeah, I guess it does. That's for sure. So Adam was asking, what do you see as the best option for device identity now in the future? Is it still X509 certs for the device identity piece? Or?
I think that's a big open question. There's a lot of discussion going on as to what should be people should be doing for identity. I'm going to say that's work in progress, and go join in the groups and start the discussions there. Because I don't know
but right now, is it the most used option, I guess?
Well, I'm not an expert on the devices. Okay.
Yeah.
When we're actually talking about devices to products, I know X509 is very popular, but I don't feel comfortable being explicit as to what is the most here right now.
Right.
If there's other people I could point you to that I think would do
No,
a better
that's great. No, that's great. I can tell you in DoD for sure that the most used today is definitely X509 device identities. I've yet to see anything much else other than having no identity, which is not great. So that makes sense. So like always, what we do is I'm gonna in a second give you the last words, but I'm just gonna tell everybody who is gonna come on the show next for next week. And so before I give you the floor for the final goodbyes, I'm gonna go now and remind everybody that next Tuesday we're gonna have CJ Eunice from the Space Force, who has a pretty amazing background. He was a Marine, he was a federal agent, and then now he's a civilian working, and he was at the New Mexico DHS to work on critical infrastructure, and now he's doing a lot on the supply chain risks, and of course he has such a pretty amazing breadth of knowledge between the physical, the virtual, and the kind of the supply chain very concerning threats we're seeing, particularly after what happened in Ukraine, but also COVID, and of course potentially Taiwan. So it's going to be a fun episode. So don't miss it next Tuesday, 1 p.m. Eastern. And now over to you for the last word. Of course, wanted to thank you for joining us. It was amazing. I know we took a lot of your time, but I think with the number of people that learned today, I think it was your time was well spent. So,
well, thank you very much, and very much enjoyed being here, and the excellent questions. I guess the last thing I'll just sort of say is, if people are interested in aerospace, I would encourage you to sort of catch the ELISA is going to be having a summit. It's free to join virtually. And if you're interested in the aerospace area, I'd encourage people to check out the formation of that group and see if that's something you're interested in participating in. Again, you don't need to be a member to join, but it certainly is always appreciated. So these projects are all open source, and they're all open communities. So encourage people to, if things sound interesting, just please reach out. Thank you.
All right, thanks everybody. You stay safe, and please keep up the great work to make sure that our kids have a fighting chance at winning against China 20 years from now. Stay safe. See you next week.